Hi, David. Very good morning. How are you doing today?
I'm doing well, Noor. How are you doing today?
Doing good. Thanks, David, for taking time to present this session on microservices. And hello, everyone, and welcome to today's webinar on microservices. Again, good morning, good afternoon, good evening to the folks joining from different parts of the globe. My name is Noor Basha, Marketing Director at Winwire Technologies, and I'll be your moderator for today's webinar. So today's topic for the session is building microservices with Microsoft Azure. So in the next 30 minutes, we will learn how microservices is helping enterprise simplify the development of distributed cloud applications and helping bring them new functionalities to the market faster. We'll also quickly go through a couple of quick demos where you'll also see how you can build microservices using Visual Studio. So with that, let me quickly highlight few housekeeping items. As you can see on the screen, during the webinar, please feel free to post questions and we'll try to answer as many as we can at the end. And we are recording this session and we'll be sharing the presentation and the recording in next 24 to 48 hours. So with that, let me introduce you to today's session speaker, my colleague, David Armstrong. He's the VP of Technology Solutions at Winwire Technologies and brings almost 30 years of experience developing enterprise applications. So David's role at Winwire Technologies involves helping our customers envision and build mission critical applications using modern platforms such as Microsoft Azure. So with that, let me hand it over to David to take the session from here. David, over to you.
Thanks, Noor, and greetings to everyone. Today we're going to introduce microservices. We're going to walk through definitions of when to use a microservice. We'll discuss the pros and cons of using microservices, and we're going to create a simple microservice using Visual Studio. Finally, we'll cover Docker containers at a high level and also briefly look at Swagger. And then we'll end today's session with Q&A. In a microservice architecture, the application is composed of small independent services. And here are some of the defining characteristics. Each microservice implements a single business capability. A microservice is small enough that a single team of developers can write and maintain it. Microservices run in separate processes, communicating through well-defined APIs or messaging patterns. Each microservice can be deployed and updated independently of other services. Microservices have separate code bases and do not share source code. They may use common utility libraries, however. Microservices do not share data stores or data schemas. Each microservice is responsible for managing its own data. Microservices are not a layer within a monolithic application. So for instance, you wouldn't have a data access layer acting as a microservice. The main point behind a microservice is to do one thing and do it well. It will have clear interfaces and it could implement some of its own internal components. And Martin Fowler's main points regarding microservices are that it enforces modular structure, encourages a continuous delivery software development process. The services can be independently deployed, and it should be done through business-driven development. Finally, services are autonomously developed and can be independently deployed. So let's look at some of the pros of microservices. In agility, because microservices are deployed independently, it's easier to manage bug fixes and feature releases. You can update the service without redeploying the entire application and roll back the update if something goes wrong. In many applications, if a bug is found in one part of the application, it can block the entire release process. And as a result, new features may be held up waiting for a bug fix to be integrated, tested, and published. Small code and teams, a microservice should be small enough that a single feature team can build, test, and deploy it. Small code bases are easier to understand. In a large monolithic application, there's a tendency over time for the code dependencies to become tangled, so that adding a new feature requires touching code in a lot of places. By not sharing code or data stores, microservices minimize dependencies and makes it easier for new features. Teams can pick technology that best fits their service. Using a mix of technology stacks is appropriate. I would encourage your company, though, to govern the technology so that you don't have technology sprawling out of control. In terms of resiliency, if an individual microservice becomes unavailable, it won't disrupt the entire application as long as the upstream microservices are designed to handle faults correctly. And a circuit breaking pattern would be one of those patterns that you might want to employ. In terms of scalability, microservices allow each microservice to be scaled independently of others. So for instance, you could scale up on demand for a microservice rather than having to scale up your entire system based on CPU load. In terms of data isolation, it's much more easier to perform schema updates because only single microservices are impacted. In a monolithic application, schema updates can become very challenging because different parts of the application may touch the same data, making any alterations to the schema risky. So let's talk about some of the cons now. When you build microservices, you need to consider carefully about where to draw the boundaries between services. Once services are built and deployed in production, it can be hard to refactor across those boundaries. So choosing the right service boundaries is one of the biggest challenges when designing a microservice architecture. How big should each microservice be? Or when should functionality be factored across several services, and when should it be kept in the same service? Those are the types of questions that you'll need to think about up front. A basic principle of microservices is that the service manages its own data, and this keeps the services decoupled but can lead to challenges with data integrity or redundancy. The use of many small granular services can result in more inter-service communication and longer end-to-end latency. Good API design is important so that the services remain loosely coupled and can be independently deployed and updated. In terms of complexity, a microservice application has a lot of moving parts. Each service may be simple, but the services have to work together as a whole. A single user operation may involve multiple services. In terms of communication between the application, when you decompose an application into many small services, how should clients communicate with those services? Should a client call each individual service directly or route requests through an API gateway? Monitoring a distributed application can be a lot harder than a monolithic application because you must correlate telemetry from the multiple services. Okay, so let's talk about building a microservice inside of Visual Studio. First off, they have small footprints and are relatively lightweight. You need very little to start. The ASP.NET Core framework and an object request mapper like Entity Framework Core. Entity Framework Core is an ORM that enables .NET developers to work with the database using .NET objects. .NET Core is a free cross-platform, open-source implementation of the managed framework. It supports console applications. ASP.NET Core is an application model built on top of .NET Core. Often, it's used in applications for refactoring large enterprise applications into microservices. So some scenarios when to use .NET Core. When you need to be cross-platform, you can use it when the application needs to run on platforms such as Windows, Linux, and Mac OS. Today we're discussing microservices. This is a great use case for it. Docker containers, which we'll discuss a little bit later, also lend themselves well to this framework. And if you have a high performance and scalable system needs, Microsoft does recommend running .NET Core with ASP.NET Core for the best performance and scale. So some scenarios when not to use. Windows API, Windows Forms, WPF application, and web forms are not supported, right? So if you need to stick with those technologies, you'll need to stick with the .NET standard. If you need to create a WCF service, you still need to stick with the .NET standard. You could try to refactor and use the REST API, similar to what we're doing today. If you're dependent on third-party libraries that are built on top of .NET Framework, that may be another issue. Then if you're missing features, so for instance, Entity Framework Core and Entity Framework V6 are not exactly in parity with one another. So you may need to use some existing features. And finally, if you need to access Windows-specific APIs around the registry, WMI, etc., you may still need to stick with .NET Standard. Okay, so what I'm going to do is I'm going to switch into demonstration mode. So let me see. What I've done is I've created a SQL server called with mark records and one table called mark records, and I added one record to the table. And what we're going to do for the microservices, we're going to implement the CRUD features, right? So that's so that we can create, update, delete, and also display the records. So that's what our microservice is going to do. Okay, I also set up, you know, a lot of people will disable Windows firewalls when they're running locally on their machines. As a best practice, I created a SQL inbound rule. And part of that inbound rule is to look at the advanced to see that it runs public. I'm sorry, that it runs on the private, and then I open 1433. Okay, I also installed the .NET Core framework. I installed Hyper-V but didn't configure it, and I installed the Docker desktop. Okay, so those are the kind of the setups for this. So let's go into Visual Studio. Okay, what I've done is I've created a blank Visual Studio project, and we're going to start working with it. So we're going to add a new solution, a new project, I should say. All right, it's ASP.NET Core Framework, and we're going to call it the Mark Record Microservice. I'm not sure on my capitalization here. I may bear with me for one moment. Thought that I took that out. Okay, it's going to bring up, we're going to target .NET Core, ASP.NET Core 2.2. We're going to use the API. There are some other templates here if you want to code everything from scratch, but we're going to stick with the API. We're going to enable Docker support. We're going to make sure that its target is Linux so that it'll run on either Windows or Linux containers. We're going to leave HTTP configured, and we're not going to discuss the authentication right now. We're going to leave it as open authentication. It's probably a subject for another webinar. Okay, so it's going to create the shell, and it brings up this page where we can get started. I'll just close that page. What we can do is we can look at the launch settings. If you remember, in Visual Studio, there used to be a startup page for the .NET Core framework. That's not necessarily true. So what we're going to do is set up our start page here. And this is going to be API/values. It created a default controller called values, and we're just basically going to replace that through here. And you can see that it did that for our Docker support. Okay, so we will close this box. In the controller, you'll see that it created this values controller. I'm going to delete it, and then we're going to start adding our stuff. Okay, so what we'll do is we'll add some folders. If you're familiar with MVC, these folders should be pretty familiar. We're going to create a models folder, and we're going to create a data access layer folder. And then we're going to add some new classes in here. So we're going to create a class that will bring the data in and out of the database. So we're going to call that the Mark Record. Okay, and then we'll go into my demo and grab this. So basically, again, this is the Mark record that we're creating. And you can see that it's got an ID, which should be used to talk to the entity framework. It's got a header, a tag, and a field. These guys are more complex in all reality, but we're going to just keep it pretty simple. Then what we're going to do is we're going to add another class to talk to the data to the entity framework. Okay. It's called the Mark Record Controller. Right. So if you're familiar with these controllers in the entity framework, we're just going to create one of these. And again, I'm going to grab the Mark Record. I'm sorry. Let's rename this. They're context, not controllers. Okay, yes, that's fine. Now we'll go back to our demo and we're going to grab the Mark Record context here. Okay, it's going to inherit from DB context, and then we'll discuss this a little bit later. But basically, for the wizard to work, we need to communicate with SQL Server directly, and we need to add some support for the entity framework. So we'll go into our NuGet packages, and we're going to look for the Microsoft Entity Framework Core. And I'm using this through the, you don't have to do all this through the user interface. You can do this through PowerShell. I'm just showing this for simplicity's sake. And then for versioning's sake, I'm also going to add one, and it's the versioning. This is a whole nother subject that you may want to cover, but basically you're going to want to think about a versioning strategy for your APIs. Okay, so we found it here, and we'll install that. Okay, so now we're ready to create our controller. You can see there's some updates here, but we don't need them for today. So we're going to get rid of that. And now we're ready to create our controller. So we're going to go into the controller and use Visual Studio to create a controller. And the wizard is going to create our CRUD methods for us. We're going to use the entity framework to take advantage of that. Okay, so we're going to choose the Mark record that showed up in the models, and we're also going to choose the data context that showed up. It's doing the work, generating the code. Okay, so it's created that. Now you can see there's no versioning here. I'm going to add support for the versioning, and it's very simple to do that here. We're going to decorate the code with API version 1.0, and then we're going to add a v1 in here like this. Okay, and that's all we have to do to support the versioning. And then we want to address this warning. What we're going to do is some dependency injection so that we can read from the app settings development file instead of hard coding the SQL Server in here. And so what I want to do is get rid of this. I'm sorry, I want to turn this code on, and I want to turn this code off. Okay, so we'll do that. Finally, the last thing I think we need to do, let me check this. Okay, we haven't added the SQL Server connection string yet, so we'll go in and add that. Okay, so we'll, you can see that we've got the connection string in the app settings. This is very similar to what goes on in the web config. So now it's added in here, and then we need to come into the startup, and we need to tell it about our DB context. Okay, so we'll do that finally, and that's here. And I'll show you that in just a minute. Okay, so what we did was we're going to do our dependency injection, which is to add the configuration into the controller. This is the code that does the versioning, right? That's very simple. And then we add the DB context into Mark record. Now, I believe we've built everything. Okay, the build succeeded. We're set to run through Docker here, so let's see if this fires up for us. Okay, we hit a breakpoint. That's good. We'll continue. We hit another breakpoint. We'll still continue. And we got our information back. Okay, so what we did was we created the microservice and we actually read a record from the database. Okay, so that was our first piece, and then I'll come back after the next bit and we'll add the Swagger information in. Okay, so let me shut this down. Okay, and we'll switch back to our presentation. Okay, so we just finished the first demonstration. Now we're going to talk a little bit about containers, and then we'll come back and we'll talk about the Swagger. Okay, so a container is a standard unit of software that packages up code and all of its dependencies so that the application runs quickly and reliably from one computing environment to another. Container images become containers at runtime. Containerized software will always run the same regardless of the infrastructure. Containers isolate software from its environment and ensure it works uniformly despite differences, for instance, between development and staging. So Docker is regarded as an industry standard for containers so they can be portable anywhere. Containers share the machine's OS kernel and therefore do not require OS application, driving higher server efficiencies and reducing server and licensing cost. Applications are safer in containers. Docker provides strong support for isolation capabilities. Okay, this is an example of how you could host everything in a container. In this case, the database server is also hosted inside of the container. One of the biggest advantages of the Docker-based architecture is standardization. Docker provides repeatable development, build, test, and production environments and allows each team member to work in a production parity environment. Running a database server within Docker container is great for development environments because you can have all your dependencies up and running without needing to provision a database in the cloud or on-prem. But for production purposes, running a database server in a container is not recommended because you do not get high availability with this approach. For a production environment, it's recommended that you use Azure SQL DB or any other database technology that can provide high availability and scalability. So for example, on NoSQL approach, you might choose Cosmos DB. All right, let's move on to API testing. So you can generate Swagger metadata automatically through Swashbuckle, which I'm going to show to provide a description of what your service offers. The Swagger is a framework for describing an API using a common language that's easy to read and understand for developers and testers. And the Swagger UI is a layer on top of Swagger. It's a tool that generates a web page and documents the APIs. So it's a great tool for developers and testers to understand any endpoints they are testing. So let's add Swagger support to our microservice. Okay, so I'm going to switch back into demo mode here. Okay, so I'll get rid of that. There's really only two things that we need to do to our project. Okay, we've already created the microservice, and that's well and good. I think one of the things I'll do, well, you know what, I'm not going to tempt fate. What I'll do first is I'm going to go back to our NuGet packages, and we're going to add Swashbuckle, just like we talked about in the slides. So if we do swashbuckle.asp, I believe that will find the second one here, so we're going to install that. And again, you can do this through PowerShell. I'm just showing it for simplicity's sake, so it's added. And then the last thing we have to do is add Swashbuckle support in our startup. Okay, so if I go back to startup and grab the latest code, let me add that in. Okay, so what it did, we simply added Swagger generation support in our startup, and then finally we told it to use Swagger and use the Swagger UI and configured an endpoint for it. Okay, so let's fire this back up. going still. I didn't remove them, and I really didn't just keep moving around here. Okay, so we've got that, our services back up, and instead of invoking that, we're going to use Swagger here to show you the nice UI that it generates. Okay, so in this case, we can grab all the records, right? This is the one you've been seeing all along. Okay, so we execute that. Okay, it goes in here, it breaks into Visual Studio, and here you can actually see some of the work that's going on. Okay, so it brought back all of the records. In this case, there's one. Okay, now if we want to look at grabbing one record, we can try that out. And again, you can see this is the API. Here's the description. Let's try it out. It says I need an ID. It knows that it's an integer. So what I'll do is I'm going to put the number 1 in here, and I'm going to execute that. Okay, it's coming through, and okay, what it did is it actually pulled back the record. Okay, if I pull in a 2, we're back in here. Okay, in this case, we're going to actually see that it is null, and it's going to return not found. And you see that that happens down here, that not found is shown. Okay, and then finally, the Swagger API will do things like if I try to put invalid data in here, it'll bounce and tell you that that's unacceptable. Okay, so that kind of wraps up our demonstrations. It's easy to add Swagger UI to your applications. And I am going to conclude this part of the presentation and turn it back over to Noor here.
Yeah, thanks, David. Thanks for taking us through the quick session as well as a quick couple of demos. So as we wrap up the session, I have a couple of questions coming from the audience. The first and foremost is if you could just talk a little bit about a well-defined API or messaging pattern, that would be helpful.
Right. So again, using a well-defined API or a messaging pattern, a lot of our customers are using Kafka to ingest messages, right? So their microservices will be sitting on top of or monitoring a Kafka queue, or any type of queue for that matter. And they will ingest the message, they'll process the message, and then they will reply out on a Kafka queue so other microservices, or other subscribers, I should say, because it's really a topic that they're subscribing to, can process those messages, right? So that's the type of well-defined API or messaging that we're seeing. Again, you're not providing any backdoor type of APIs that special microservices will expose. Okay, so what you want to do is make sure that the APIs you do expose are well defined and documented. And again, Swagger is a good step in helping you do that.
Great, thanks. So another quick question is, do I need to use Visual Studio Enterprise to build the microservices?
Great question, Noor. No, you can actually use Visual Studio Community Edition, which is free for download. I haven't used it personally, but I know that you can use it. I just happen to be using the Visual Studio that came with my particular MSDN subscription. If you want to do more command line type of work, you can also use Visual Studio Code, right? So Microsoft supports the development of microservices very nicely, and you don't have to use their high-end tools to do it.
Great. Thanks, David, for taking up that question as well. I know we are already over time, so there are a few more questions, but we would like to take them offline. So as you can see, if you have any questions, you can reach out to us at marketing@winwire.com or on our Twitter handle @winwire. So before I wrap up, I just would like to highlight on the upcoming webinar. What we have is on the Azure Active Directory, which is again on the March 21st at the same time, 9 AM Pacific and 12 PM Eastern time. Thanks again for joining this session. I hope you found it useful and informative. Thanks, David, for quickly walking us through how you can build microservices using Azure.
Sure, thank you, Noor.
Have a good day. Bye.